polynomials. Okay.
Okay.
So the first thing is that they might ask you some questions like, well, is this a polynomial or is it not? And we'll wait until you actually have some to look at to give you that information here.
Mhm.
But then they typically start out with a topic. And actually, I'm going to go grab a standardized test question because this is actually pretty easy to show
Okay.
with these. We'll mix it up a little bit. Have you taken the PSAT yet, by the way?
No, we haven't.
Okay, I know that's coming. Like you might see it next year for sure.
Mhm.
And it's going to cover a lot of things you already know. So let me grab, yeah, here's a good problem for us to look at. So there's operations you can do with polynomials, and the first one is to add polynomials. Okay, this one is an addition problem here, and a lot of students will wonder, well, why are there parentheses around these terms? Okay, so on the left there's 2x plus 6, that's 2 terms, binomial, trinomial on the right, 3 terms. You only need the parentheses in 2 conditions. If there's a subtraction before or a number before. Otherwise, they're extra, they're unnecessary. So in this case, there's a plus. So we have 2x plus 6 plus x squared plus 2x plus 1. And from here you need to do what's called combine like terms.
Okay.
Do you understand what I mean by that? Have you heard that before?
Yeah.
Okay. Could you try combining like terms here if that's clear?
So it'd be the 2x and then the 2x on the other side,
Yep.
and then the 6 and the 1.
Okay. And what does that combine to?
So it'd be 4x squared plus 7.
So you're adding. So it's 2x plus 2x, 2 eggs plus 2 eggs, 4 eggs.
Oh, okay. So you
Okay.
don't add, so it doesn't become squared.
Not yet. That's something slightly different that we'll see.
And then plus 7.
Plus 7. And we're missing the x squared, which comes out in front.
Okay.
Plus 7. Yeah. Okay. So the not too bad, at least at first glance here. So you raised an important sort of question here, which is like, what is a like term? A like term is the variable variable to the same power.
Okay.
Okay, so for example, like x plus x, there's really a 1 in front of both of these. That's 2x.
Mhm.
Okay, x squared plus 2x squared. Well, there's 1x squared, or 1 egg plus 2 eggs.
Mhm.
There's 3 eggs, 3x squared. Okay.
Okay.
So here's where that gets tricky. And that's, this is the new problem here is what if I ask you for 4x minus 3x squared plus 6x minus 2x squared? What are the like terms that you see here? What does 4x go with?
The 6x.
So positive 6x, notice I take that sign with it. What does that
Mhm.
combine to?
So 10x.
10x, very good. And then a little bit harder here, minus 3x squared, that operator goes with it, minus 2x squared. What does that become? What does that go with?
Would be 5x to the 4th.
So notice you kept, when you added the x's, it stayed x to the 1.
Mhm.
The x squared is going to remain, like the answer is going to be x squared. And you're
Oh,
just looking at the numbers in front.
so it'd be 5x to the
My,
same.
minus 5x squared.
Oh, okay.
Okay, because they're both negative, so the answer would stay negative. Okay.
Okay.
All right, so let's have you try one here on your own. See if this makes more sense. Let's go a negative 6x plus 3x squared minus 2x plus 4x squared. So if you could work that out for me and give me your final answer.
Okay. Okay, I got negative 8x plus 7x squared.
Good, very good. Okay. So now it extends from here. Like it's not just, x's and x squareds. It can get greater in powers. So we're going to
Okay.
look at that in the next problem here, which I'll do a standardized test format for you. So here is a question. And again, like we talked earlier, like why are there parentheses around the first three terms? Why are there parentheses around the last four terms? The answer is they're not needed because there's a plus in the middle. With a plus, you can drop the parentheses. So what you're really just looking at is 12x to the fourth minus 5x plus 18 plus 6x to the fourth plus 13x squared plus 7x minus 9. You want to combine like terms. So again, the exponents do not change when you add.
Okay.
So give this a try. I just want a letter A, B, C, or D.
Okay. I got C.
Okay, and how confident are you in your answer?
I'm confident.
Pretty confident. Okay. Yeah, so that looks good. 13x squared plus 2x. Yeah, perfect. Okay. So here's a new problem for us to look at together. And these are legitimate, by the way, these are legitimate standardized test questions in the SAT, ACT. So
Okay.
it's good that you're able to answer them. It's a good sign. So I'm not putting in the multiple choice here. Again, the parentheses are not needed. Like they're distracting. So you read those 1x cubed plus x plus 1x plus 1x squared minus 1x. Notice that the two x's go away because you've got one positive and one negative, and so they
Yeah.
cancel out. You don't write 0x, you just leave it. So your final answer here is the x cubed plus the x squared. Okay.
Yeah.
All right. So you might feel like, hey, I've got it. And then I, of course, throw a little wrinkle at you. Let's say I tell you 2xy plus 3xy. Are these like terms? What do you think? What's your intuition tell you?
Yeah.
They are. They absolutely are. They've got the same variables to the same powers. This is 5xy. Okay. Now, but what if I wanted you to do 3x plus 2y? Are these like terms?
No.
I agree, they are not. But what if I do this? What if I put a y here and then an x here? Does the order matter when you're multiplying?
No.
It does not matter. So these actually are like terms. You probably won't see them scrambled like this, but this is something to think about here. So
Okay.
here is a problem that you will see though. 5xy squared minus 2x squared y plus 3xy squared minus 4xy. Okay. So here's a problem you might see, and it would say the instructions are pretty basic. They're like simplify. Okay. Simplify. And that just means to reduce, combine like terms. Tell me what you see as far as like terms here,
Okay.
if any.
Okay. The 5xy to the power of 2,
Okay,
and then the 3xy to the power of 2.
good. Those are like terms. What do they combine to?
8xy to the power of 2.
Good. All right. Anything else?
No.
No. Minus 2x squared y minus 4xy. Okay. So sometimes you can, sometimes you cannot combine these things. Okay. So one more standardized question here. And then we'll move into some harder ones, subtracting and some other things.
Okay.
But Mom said your grade's gone up a little bit in class. It's great to
Mhm.
hear.
Yeah.
Whatever you're doing, keep it up. It's working.
Mhm.
Okay, so go ahead and try this one out on your own. I just want your final answer, A, B, C, or D.
Okay. I got A.
Okay, let's take a look here. So notice, and this is a kind of an SAT thing, test taking strategy thing, is sometimes you look at the answers here and you're like, oh, they all have that in there. So in
Mhm.
terms of how you would do this for an SAT, you would actually not look at that term at all. You would
Mhm.
notice that some have an 8 and some do not. So the
Mhm.
question is like, does the answer have an 8? And notice -4 and +4 become 0.
Mhm.
So it's either A or B. So you can, you get down to there. So now we're down to -5x as +5x as answers, +3x, -5x. So yeah, it is letter A. Okay.
Okay.
Have you seen this before in class?
Yeah.
Oh, good. Okay. So let's move to the more difficult stuff here, which is subtracting. Um,
Mhm.
and just talk a little bit about that. So let's say I give you something like this: 4x minus 5 minus 2x plus 1, and there's a subtraction in the middle here. So notice there's no subtraction or plus on the left. There's an implied one, an implied plus here, but this minus goes to the right. And there's kind of two ways to think about it. You can either think of this as -1 right here, and you're multiplying in by -1, or you can think of it as changing the signs inside.
Mhm.
Okay. So for example, here we got 4x minus 5 minus 2x. So it was positive. Now it's negative, -1. And then you would combine like terms from here. So that 4x goes with the -2x, positive 2x, -5, -1, -6. You will see this kind of stuff on standardized tests. You have to remember to distribute the negative to both there.
Okay.
Okay.
Mhm.
So let me see if I can find one real quick for you to try, or I will make one up.
Mhm.
Yeah, here's a good one. It's a little bit harder than what we just did. Since you said you've seen this before, I'll just start transitioning to what I think might be newer stuff. But here we go. You want to try this one on your own, please?
Mhm.
How are you doing on this one?
I'm almost there.
Great.
Okay, I'm pretty sure it's A.
Okay, so I'm just gonna, I'm mostly concerned about how you distributed that negative 2x squared minus 4 plus 3x squared minus 2x plus 7. Again, you just change the signs there. So now it is 5x squared, so it's either A or B, minus 2x, and that means for sure it is A, plus 3. All right, it's very good. Okay, so since you seem to understand that, let me go back to the previous problem that well, let's just talk about this. So we've basically covered adding and subtracting polynomials. Okay.
Mhm.
And the next logical extension is multiplying polynomials. Okay.
Okay.
So here's what I mean by that. Let's say there's a 2x here, and it's 1 plus 3x minus 4x squared inside here. Okay.
Mhm.
And these, this first thing is a polynomial. It's just it's a monomial, it's one term, but it is a subset of polynomials, but you're distributing that in to everything. Like everything is going to get multiplied by the 2x. Okay.
Okay.
So one way to write this is 2x times 1 plus 2x times 3x, excuse me, minus 2x times 4x squared, like that.
Okay.
Okay. And now this is like, well, this is why you learned all the stuff you just learned, is
Mhm.
can you, reasonably simplify this? So there's the 2x times 1, that's probably not a big deal. That's just 2x. Okay.
Mhm.
But 2x times 3x, and you were asking me about this earlier. I'll just say the obvious, it's multiplication because they're squeezed together. But 2
Mhm.
times 3 is 6, but x times x is now x squared.
Okay. Yeah.
Okay. And then as we keep going here, you've got 2x times 4x squared. 2 times 4 is 8, x to the
8x.
1, 8x cubed. Very good. All right. So this is kind of your starter question here to see if, do you fully understand this?
Mhm.
And it sounds like you do. Let me just give you a quick standardized test question here that's kind of related. It's an
Mhm.
easier one than this we just did, but then I think it's good to kind of sprinkle these in every once in a while. So go ahead and distribute that 3 to both terms and then simplify and give me your final answer here.
Okay. Yeah, I got C.
Okay, so we got 3x plus 15 minus 6, 3x plus 9. The answer is definitely letter C. All right.
Mhm.
So, again, here's where it gets more difficult. Okay. I gave you something like this, like x minus 3x squared,
Mhm.
and I put a 4x out in front. Okay. But then I say we're going to subtract 4 times 5x squared minus 4x cubed, like that. Okay.
Mhm.
And this is, I'm really, I'm increasing the difficulty quite a bit here because everything you've done so far, you've already known how to do. But let's work this one out together. What is 4x times x? What does that become?
4x to the power of 2.
4x squared. Good. And then 4x times minus 3x squared, what would that become?
Negative 12x cubed.
Good. Now this is where you got to be very careful. I would treat it as you're multiplying everything by minus 4,
Okay.
not minus 4 times it. So minus 20x squared.
Mhm.
Okay. And then minus 4 times minus 4x cubed is positive 16x cubed.
Okay.
Okay, so that would be my preference is to really, and you keep seeing me circle it with the operator so that you know what it is.
Okay.
Okay, so in terms of like combining like terms, we got minus 16x squared, and then we've got minus 12x cubed plus 16x cubed. That's 4x cubed,
Okay.
like that.
Mhm.
Are there any questions on what you have just seen?
No.
Okay. So a few just, relatively basic, standardized questions for you to think about here. Have you
Hmm.
tried this one? Got one more after this for you to try.
Okay, I got 2x cubed minus 6x, or yeah, minus 6x to the power of 2.
Okay.
So yeah,
Letter D sound good? Okay. Let me give you
yeah.
one more of these to try. Um,
So when I'm multiplying the 1x to the fourth times the -8, do I carry over the to the power of 4 to it or no?
you do. So think of it as 8x to the 0 power
Hmm.
here. I mean, you don't have to write this, but this is one way you can visualize. So it's 8x to the 0 times 1x to the fourth. And then
Hmm.
because the bases are the same, you add the exponents.
Hmm.
And that's why you do bring it through.
Okay.
All right.
So then I got 3x to the sixth plus 9x to the fifth minus 8 to the fourth.
Okay. Well, which letter would you select? A, B, C, or D?
Um, B.
Yes. Very good. All right. Okay. So let me give you one here that's not it's a more free response we'll call it, but let's go 4 minus 2x minus 2 5x plus 1. This will be our last one before we move into something else.
Okay.
Pretty sure you'll be able to get this, but just take your time, pay attention to signs as you're moving through it.
Hmm. Okay, I got negative 12x plus 6x to the power of 2 minus 10x minus 2.
Okay, so this is really good, but what is the final answer? This is not the final answer.
Oh, yeah, okay. Okay, I got negative 22x plus 6x to the power of 2 minus 2.
Very good. Now you probably noticed this in some of the problems that we're doing. I'm just going to scroll back and look at them. The answers were all in what's called a descending form. So notice the exponents went down from +6, 5, and 4. Even the ones that were wrong went down from 8, 5, and 4, and so
Mm-hmm.
on, like cubed and 2. This one had just an X and then a number, and so on here. So your answer, while correct, may not be preferred. The teacher might say, hey, you know what? I really want it in this format,
Yeah.
and this is called standard form.
Mm-hmm.
I don't care, but I'm not grading your test. So,
Yeah.
okay. So have you heard about the FOIL method for multiplying binomials?
Yeah.
Oh, fantastic. And you're already comfortable with that?
Yeah, I'm pretty comfortable with it.
That's fantastic. Okay. Have you guys done any solving quadratics? Something, here would be a starter problem like x squared equals, we'll go 64.
No.
You've not done anything like this. Okay. So we're going to talk about the square root method. So let me back up here. So there's a number of methods that you're going to learn to solve quadratics. So the first one is called the square root
Hmm.
method, and literally you take the square root of both sides of the equation. Now, but before we do that, this is what the graph of x squared looks like. This is what 64 looks like. How many times does it hit the graph?
Um,
How many times do they intersect?
Twice.
Twice. Not a trick question, 2 times. So there should be 2 answers. So when you take the square root of both sides, it's plus or minus the square root of 64, plus or minus the number. Like it's not just the square root of 64. You are taking plus or minus, meaning 2 solutions, because you generally get one negative and one positive. So in this case, it would be plus or minus 8.
Okay.
Okay. Now, before we get into these, remind me again, are you allowed to use a calculator?
Yeah.
Awesome. Okay, so let me just pull up some problems here for us to work on. Uh, these are not as easy to make up as you might think. Okay, this isn't what I wanted. Okay, let me make one up here. So let's say it's x squared minus 3 equals 13. And this said to solve. Your goal, much like a linear equation, is to isolate the x squared. Okay. So that means you're going to add 3 to both sides. Like you want the x squared to be alone. X squared equals 16. And from here, you can take a square root. You take a square root of both sides, but on the right, it's plus or minus each time. So this is going to be plus or minus
4.
4 as your final
Okay.
answer. Okay.
Okay.
Just needed a moment to find some more problems here for
Hmm.
us. All right. Okay. None of these. I don't like any of these. Okay. So here's another one, kind of this flavor here. Minus 5x squared equals minus 500. Okay. So when you're solving this, you really need to isolate, just like before, x squared, not x, but x squared.
Hmm.
And to do that, what are you going to do here to isolate the x squared to get it alone?
Add 5 to both sides.
That would be true if this were subtracted. Because they're squeezed together, it's multiplying. This number
Oh,
is multiplying here. So you undo that with division. X squared equals 100.
okay.
What would be the final answer in this
Um,
case?
X equals plus or minus 10.
Yes, and you'd be surprised how often you forget to write them both. So somehow make it clear to yourself, I better write down both answers to this.
Okay.
All right, so let me grab another one here. Yeah, here we go. So it doesn't have to be x. Of course, it could be another variable like 9n squared plus 10 equals 91. Okay.
Okay.
And so here, like you want to treat it, the analogous problem here is what would you do if you were solving 9n plus 10 equals 91? Which would you undo first, the multiplication by 9 or the addition by 10? Your focus needs to be on the side with the variable. Okay.
Okay.
So, consider that here. Are you going to undo on the left here, not multiplication by 9 or the addition by 10? Do you recall?
Probably the multiplication.
So it's based on this.
Oh, okay.
And this is the simplify. We're not simplifying now. We're going the other way. We're solving. And I didn't know this even existed, but a student actually said that is it a SAD MEP method. I had never heard that before, but I guess if you say this backwards, it sounds like SADMEP. But you undo addition, subtraction before multiplication and division.
Oh, okay.
Okay. So in this case, you're going to undo subtraction, addition by 10 by subtracting 10 from both sides. So we get 9n squared equals 81.
Mhm.
What do you do next to solve this?
Would you divide by 9 next?
Divide by 9. So we have n squared equals 9. What are your final answers?
N squared equals 9, and then n squared equals plus or minus 3.
N equals plus or minus 3. So you undo it with plus or with the square root, and it's just n. You're just solving for n.
Oh, okay.
Okay, so here's one for you to try on your own. 7v squared plus 1 equals 29. Take a look at that. Let me know if you have any questions along the way.
Mhm. I got v equals plus or minus 2.
Very good. That is correct here. Okay, so let's look at another problem here that maybe it appears at first glance like it's not possible. Let's just say I wanted you to solve something like this: x minus 1 squared minus 5 equals minus 4. Okay, now this looks very different than what we've just been doing, and in some ways it is. But if I asked you to solve x squared minus 5 equals minus 4, what would you do first on the right to solve this?
Would you add 5 to both
Yeah,
sides?
you would add 5 to both sides, and you'd have x squared equals 1. Well,
Mhm.
let's try that on the left. Okay, let's just see if that works, because it worked on the right, maybe it works on the left. Okay, so we have parentheses x minus 1 squared equals 1.
Mhm.
Okay, now this is good, because when you take the square root of the left, the square root undoes the square.
Okay.
So it literally, it goes away. And some students, what some students do is they go from the line that I'm showing with the arrow to the line where the arrow ends. Like they don't even, they just show the end result here. Okay.
Mhm.
Now what we have here is actually what's called some students call it a case 1, case 2. It's really two equations. It's x minus 1 equals positive 1, and x minus 1 equals negative 1.
Mhm.
And from here, there's a bit more to do. You have to add 1 to both sides. So x equals 2 on the left, and x equals 0 on the right.
Okay.
So notice we just go back and look through this problem one more time. Just because the x was in parentheses, we didn't do anything different. We isolated the part that was squared. Then you take a square root of both sides. The difference is kind of this case 1, case 2. Okay,
Mhm.
so we'll look at a more basic problem here to begin with. Let's say it's x plus 3 squared equals 81. Okay, so to solve this, you're going to take a square root of both sides. X plus 3 squared equals plus or minus square root of 81.
Okay.
Okay, now on the left, the square root undoes the square.
Mhm.
So you're left with just x plus 3 equals plus or minus 9 on the right.
Mhm.
And this is the case 1, case 2. They do expect you to write them both out. Equals +9 equals -9. It's maybe analogous to like you drop 2 plays in the huddle, and depending on what the defense does, you run one or the other. I mean, here we kind of got to solve both, but maybe you practice both or something.
Okay.
But you're not done until you get X by itself. You got to get to where, and it's always the same operations. Okay. So you get X equals 6 and X equals -12.
Okay.
Any questions on that before I give you one to try here on your own?
No.
Okay. So let's say it's X -3 squared. Oops, that's actually change this over. X -2 squared equals 64. Go ahead and solve that for me, please.
Okay. Yeah, I'm kind of confused on this part now.
Okay, so you're going to take the square root of both sides.
Yeah.
X -2 squared equals plus or minus the square root of 64.
Mm-hmm.
On the left, it's just X -2. It's the same thing as the first line, no exponent though. Okay.
Yeah.
Now on the right, what's the square root of 64?
8.
Plus or minus 8. So you write two equations. X -2 equals +8. Okay, so basically the same thing on the left. X -2 equals -8.
Okay.
Go ahead and solve these from here, please. Let me know what you come up with.
Okay, I got X equals 10 and X equals -6.
Okay. All right. So let's have you try one more here. Or actually, let me help you through this one. So let's say it's 2 times X -1 squared equals 32. Like again, there's kind of this like there's always like an analogous problem here. Like, what would you do if it was 2x squared equals 32? What would you do to solve this?
Would you divide by 2 on both sides?
Divide by 2, and you get X squared equals 16. So from here, for on the left, so what you want to do on the left is you want to divide by 2. Okay. So for this, I would like you to try solving it from here and let me know what you come up with.
Okay. Okay, I got X equals 5 and X equals -3.
Yes, that's correct.
Okay.
Perfect. Okay. So let me have you try one here, kind of start to finish. A couple of these with all the little wrinkles and warts that we've been talking about here.
Okay.
All right, let's go 2 times X -4 squared plus 10 equals 210. Okay.
I think I might have done something wrong because I don't think there's a square root of 105.
There is not. Did you subtract 10 from both sides?
Oh, no, that's not what I did.
Okay, so take it from there.
Okay. Okay, I got x equals 14 and x equals -6.
So that does sound right here. So you get it down to 2. Just going to show this in case you want to look at this later. And you were wise to say, well, that doesn't look right, Matthew. Like, I don't know how to take the square root of 105. And you're supposed to know how to do most of these up until now. So you get x minus 4 equals plus or minus 10. And you're spot on there. X minus 4 equals 10. X minus 4 equals -10. So x is 14. X is -6. I think that's what I heard you said.
Yeah.
Awesome. Okay, so this is great stuff here. Kind of some variations on this that you might see. Here's a problem that is truly it's one like what we've been doing, but it looks a little bit different. It would say to solve here. You're used to having numbers on the right. So you just move it to the right. You would just add 49 to both sides, and you get x minus 6 squared equals 49, and you would go from there. So could you work this one out from here, please?
Yeah. Okay, I got x equals 13 and x equals -1.
Really good. So another thing we can do here is I can show you is that we can check these. We can actually go back and type in or put in 13 minus 6 squared minus 49 equals 0. That's 7 squared minus 49, and that's 49 minus 49. That does in fact equal 0. You can also do the same thing for the other one there. All right.
Okay.
So another thing, we're going to get down here to the end, but other problems you might see something like this, like 9x squared equals 1. If we divide both sides by 9, you get x squared equals 1/9. You can take the square root of a fraction. So you can take the square root of x squared plus or minus the square root of 1/9. This becomes plus or minus square root of 1 over square root of 9, which becomes 1/3.
Okay.
Okay. So here's the only thing you cannot do. And this is one of the math commandments. One of them I think you already know is you can never divide by 0. You've seen that before. The second, until you're told otherwise, you cannot take the square root of a negative.
Okay.
So let's just say, and I'll just do an example here. Let's just say it's minus 2x squared equals -8. If you divide by -2 here, it's now x squared equals 4. And this is okay. This is totally okay. But if it were minus 2x squared equals 8, and when you divide by -2, x squared equals -4, this is really bad. Okay,
Okay.
you don't know
So
how to do it.
in order to divide by a negative, they both have to be negative?
Well, the number, the answer is whatever is on the right has to end up being positive or
Okay.
zero or zero.
Okay.
So here's two possibilities. One is you made a mistake doing your algebra. The
Mhm.
other is that there is truly no solution. Okay,
Okay.
but these are exceptions. These are things you know you don't want to think too much about
Mhm.
for